So today I'm going to give you an in-depth tour of this beaut little amplifier, the NAD 3120. If you're thinking about getting one for yourself, hopefully give you some more information about it and maybe give you some tips on why you should get one too. This is the so-called audiophile version of the 3020, the famous NAD 3020. It's so famous it's got its own Wikipedia page. I'm not sure whether it's true that this is actually an audiophile amplifier, but it's a great little amplifier. It was made from 1984 to 87. It's rated at 25 watts a channel. And if we just start to have a look at the outside of it now, we can see that it's got that classic sort of 80s look. Although when the 3020 first came out in 1979, perhaps it wasn't such a classic look. The 3020 was so important because it was an amplifier that sounded good, that was affordable. And up until that point, those two didn't really go together. NAD kind of turned things on their head, which is why the 3020 was the most popular selling integrated amplifier of all time. And really began what we know as NAD today. They had amplifiers before that, but they were much more like your typical 1970s amplifier, you know, shiny silver and lots of knobs and expensive to build. That was the problem, expensive to build. So they really turned things on their head in terms of manufacturing with the 3020, making an amplifier that was cheap to build but not cheap in sound. And so that's why it really turned the market on its head. So if we have a look at the front panel is actually plastic. It looks like it's a big solid lump of anodized aluminium, but it's not. It's plastic. So it can be a bit prone to being scratched. This one's not. Incidentally, I bought this unit on eBay. I got it out of the UK. The price was okay. It wasn't especially a bargain, but it was sold as working, and I wanted a working one. So by the time I got it here to Australia, probably overcapitalized a little bit, but I do have a purpose in mind for this. And I bought this as an exercise also, so as you see when I take it apart, I've done some work on it as well, so this should do me for quite some time. So it has a plastic front panel, your power button there. This is where the tone controls would be if this was a 3020, but the 3120 doesn't have the tone control. So that's one of the things why it's, you know, supposedly more aimed at audiophiles. I don't know whether that's true, but no tone controls. Input selection, auxiliary, tuner, phono. Yes, it does have a very, very good phono input stage, MM and MC. Tape, the usual sort of stuff you'd expect for 1984. Mono mode and loudness. And it really is great having this loudness button because, yes, you don't have the tone controls, but if you've got speakers, if you're driving speakers that are just a bit, haven't really got much bass response, then you can just use the loudness button and just help to lift those speakers that might be lacking a bit in bass. Now, you may have noticed that there's no balance control. Well, there is. It's actually very cleverly built into the volume control, which has got this friction drive. So there's an inner knob and then an outer knob. So I've sort of switched it to the right. If I switch that all the way to the bottom volume, that stopped. Now this one can keep going, and now they're back at the same level. So very, very clever. Now let's have a look at the back. So here's the rear panel. From the left-hand side, ground connection for the turntable, MMMC switch, phono input, tuner augs. Here's your tape inputs with a DIN connector as expected. Now, this was common in a lot of NAD amps from this era, but basically the preamp stage and the power amp stage are separate, and then they're just joined like this. So what a lot of people did is they found that the preamp was very good in its own right. So they'd actually run out of here off to a separate power amp and drive their system that way if they wanted a bit more oomph than what this amplifier was capable of doing. Lab in, which has got slightly different circuitry to what the normal in is. The NAD famous soft clipping switch. Banana plug inputs. So again, when you look on the net, you'll see that people say that the thing that's different about the 3120 from the 3020 is the lack of tone control and the banana plug inputs. And that's not exactly true, because the 3120 is a variant of the 3020B. The 3020B also had banana plug inputs. If you go to the A or the earlier model, they had those horrible spring terminal things. But with the 3020B and the 3120, both models had banana plugs like so. And then up here we have impedance selector, which I'll explain a little bit later on just what that does. And of course, power in, hardwired cord. Because this came out of the UK, it had no plug on it because of those laws they have over there, which was fine because I needed a 240 volt Australian mains plug on this anyway, so I've had one of those put in. Just a top-down view, pressed metal lid. Fortunately this one's only got a few minor scratches on it here and there. And if we flip him over, the underside, again just a stamped anodized bottom panel which comes off with these screws. Let's now have a look inside. So here's our bottom panel, and as you can see it kind of flexes like so. I'm not sure whether it was like that when it came out of the factory, but it's fine because once it's got all the screws in it, it's fine. Okay, so here's our top side. Just take our lid off, and yes, it's just a painted, folded piece of steel. Then inside, just a quite simple chassis, metal rear panel. Let's turn it around so you can see the front panel. So this is metal all through here, and if we just have a closer look, this is where the tone controls are on the 3020. So you can see this is exactly the same circuit board, it's even the same chassis, because there are the holes where the knobs would go through the front panel if this had tone controls. And also we can see over here this cutout is where the meter LED board would go if this was a 3020 for the power level. So obviously it has a different front panel, but the chassis is the same, and they just don't fit the parts needed to make this into a 3120. So what have I done to this unit? Well, it was working very well when I received it, as advertised, but I did buy this as an exercise, so I've replaced all of the electrolytic capacitors. And there's three types of capacitors that I've used. Nichicon Fine Golds and Elna Silimic 2s. So basically the rationale I took was that if the Elnas would fit, I fitted Elnas, and where they wouldn't fit because of their physical size, I fitted the Nichicon Fine Golds, because basically in the same capacitance voltage rating, the Elnas are physically larger. So even here, you can see these look quite fat. The original ones that were in there were a bit smaller than that, but these still physically fitted, so I put in the Elnas. And then our two these are the two main power caps for the voltage rails for the final transistors. These are Elna for audios, so I replaced those. The other thing that I've done is fitted sill pads to the final transistors and also to these two pre-driver transistors. And then also these trimmers are new. So these two resistors, so this fixed resistor and the trim pot, they set the bias. So one channel there, another channel there. And originally, they're not trim pots. Originally, there's just two resistors there. And the service manual describes how to set the bias. And basically, the idea is that you just put in whatever value works. So I decided that wasn't very elegant, so I put in these trim pots, which makes setting the bias a whole lot more easier. This trim pot here, and his mate, which is hiding somewhere, that's for setting DC offset level. So I've adjusted the bias on this, set the DC offset as per the service manual. And the other thing that I've done is bypassed the very troublesome muting circuit, which I made a video about, because it never worked the way that it was supposed to work. So I just shorted out the JFETs for that muting circuit. So the JFETs, that's the JFETs there, and this is the muting circuit hiding down here. So yeah, I just shorted out the JFETs so that effectively the muting circuit's not there anymore. So this unit was very clean when I got it, just a bit dusty inside, so I gave it a good blowout with the compressor. It's looking very nice now. As I said, part of this was an exercise. It really didn't need to be recapped. And a lot of people out there will say recap anything that you can. Others will say don't recap. Well, I think the old saying, if it ain't broke, don't fix it, is true. And I recapped this really just as an exercise, but it didn't need to be recapped, and I'm going to show you why. This is one of the original power capacitors for the driver transistors. It looks physically in great condition. The top of it looks fantastic. We can see the date code on here, 0784. All of the capacitors that came out of this were 105 degree rated. The ones that I put in are not. They're 85 degree rated. That's what the Nichicon Fine Golds and the Elnas are. So whilst NAD built this thing to a budget, yes, they've used sort of like no-name parts, TPO. They still exist, by the way, but I'd never heard of them before in all my years in electronics. But they haven't used rubbish parts, and because if I test this part now with the capacitor tester, we see that it's as good as new. And I found that across the board. Every single capacitor that I tested, I didn't test them all, but I tested a good few as I pulled them out. They were all fine. Yes, you'll see units out there that are in terrible condition, and they genuinely do need their capacitors replaced, and you'll see units on YouTube where the capacitors have been replaced, but people generally don't make YouTube videos about a repair video or something that had absolutely nothing wrong with it. So I think it's be careful not to repair things that don't need repairing. Now, on the bottom of this capacitor, this is glue, and this is for the manufacturer. So this looks a bit ugly. At first glance you might think this is leaked. No, it hasn't leaked. This is glue, And the reason it's glue is because of the way this unit was manufactured is it's been wave soldered, and all of the heavy parts that are likely to fall out before you can get the thing wave soldered, they've all been glued down to hold them in place until the board can be soldered. So if we just have a look at the back side of the unit now. Once upon a time I ran a factory that made electronics, so it's quite interesting to see the way that this thing has been made. You can actually see by looking at the back of it, if I just move that there, so you can see how gorgeously simple it is, because this is the business end for soldering this thing. Everything's accessible. This bar comes out incidentally, 2 screws, you've got to take the front panel off, but for manufacture, obviously that's not there, and it's wave soldered, so you're wave soldering the board on its own. From what I can tell, there's very little of this thing has been done by hand. And that's just so important to getting the price down on electronics. The more that you have to do by hand, the higher the cost is. So this thing has been stuffed and then it's been put through the wave solder. And there are only 3 circuit boards in this thing. Most of it is this circuit board. And you might wonder about the strange arrangement with the alignment of the plugs on the back of the unit. Well, that's so that you don't need an extra circuit board. You don't have wiring from some other circuit board going to the main board. You just got these, this is your connectors here. So you just shove them in and solder them. And these, I think these have even been wave soldered. So here, this is your speaker terminals here, and this is your RCA jacks and so on. And so then over here, this is your headphone jack here, and over here, this little circuit board hiding down here is your volume control, and that's basically it. And the way you can tell that this has been wave soldered is, you're probably not going to be able to see it on the camera, but the component legs that I haven't reworked, that I haven't done anything to, you can see that there's solder going over the end of the leads, the component leads where they've been trimmed. If these had been trimmed after they'd been soldered, you get a clean cut. They don't have that. There's like a rounded little bit of solder going over the very end of the pin. So that tells me that these things were probably all cut to length before they were put in. Certainly the leads were trimmed before it was soldered, put through the wave solder, and essentially that's most of the electronics taken care of. So let's turn him back over and just have a bit of a closer look at the electronics. Okay, so having a look at the circuitry, we can see that here we have our power in with our mains transformer. And then here is our power supply. So there are 2 power supplies. This first one generates plus 33 and minus 24.2. So this power supply basically powers everything except for the final stage. And then just down here, this is the final stage, plus 30.5 volts and minus 30.5 volts. So these 2 capacitors, 4700 mic, that's these 2 capacitors here. So that's your reservoir for your power transistors. Now, I told you that I'd tell you what that impedance selection switch on the back does. That's this switch here, and all it does is it just changes a tap on this power transformer So if you change it to 8 ohms, then you actually get 33.3 volts and minus 33.3 volts instead of 30.5 volts. So basically you get 3 volts thereabouts extra power on your power transistors, basically just giving you a little bit of oomph. There's really no reason why you couldn't do that at any impedance, as long as you just make sure the thing doesn't overheat, and the manual essentially says that. You can run it at the higher power if you want to, just be careful of heat. So if we come up here, this stage here is our phono stage, and in our unit that's up here, just unsurprisingly right near where the phono input is. Then we have our preamp stage itself, and this is our preamp stage here. As usual for these kind of amplifier schematics, different things are grouped by designator numbers. So your phono stage is the 400s, your preamp stage is the 500s. So your preamp stage is down here. Here we see is the back of our volume control knob. And that comes out through our muting circuit that we've bypassed because it doesn't work. And then we see here is pre-out, and that then comes down here to our normal ends. So this is your power amp stage here, and on our unit that's basically over here. Our power supply regulation circuitry is hiding here underneath this ribbon cable. There's a bridge rectifier hiding there, and there's another one down here. So that's essentially it. That's pretty much all there is to this amplifier, the NAD 3120. Do I think that you should get one? Well, if you've watched this far, then I think you should, yes. It's not really what you would call an audiophile amp by modern standards, but certainly I think if you were someone who didn't want to have to spend a lot of money to get an amplifier that sounds pretty good, and you're kind of leaning towards vintage, then I would buy one of these. The equivalent of this today is the NAD C316 BEE version 2, which is a very, very nice amplifier, but you're probably going to pay about 600, 650 Australian dollars for that. Honestly, I think I'd rather have one of these than buying a brand new modern amplifier. So hopefully this has been of interest, and this has been the NAD 3120.